Hello everyone, welcome back to the channel. So in this video, we'll see how to find out the expression for the resonance frequency in RLC series circuit. So this we know that Fr is equal to 1 by 2 pi root over LC. So let's understand how this term came that Fr is the resonance frequency is equal to 1 by 2 pi root over LC. We know that in case of a series circuit at low frequencies, at low frequencies, XL is equal to omega L is negligible. negligible but but capacitive reactance is the inductive reactance. Actual inductive reactance, this is inductive reactance is negligible, but capacitive reactance capacitive reactance xc is equal to 1 by omega c is very high is very high. So this is the condition 1. So in case of in second condition means when at high frequency at high frequency xl xl increases and xc decreases. So at some angular frequency called omega r, now now at some angular frequency that is omega r, xl is equal to xl is equal to xc. So we can write, so that is, so from this xl equal to xc, if it is xl equal to xc, that is, we know that xl is equal to omega rl. So this is omega rl is equal to 1 by omega rc. Now if we rearrange, then we can write omega r square is equal to 1 by lc, or we can write omega r is equal to 2 pi f. Omega is equal to 2 pi f r whole square is equal to 1 by lc. Now from this, what we can write, if we remove this square, so in that case it will be 2 pi f is equal to 1 by root over lc. So that is 1 by 2 pi root over lc. Now again we can write f r is equal to 1 by 2 pi root over lc. So this is the expression of resonance frequency, where this fr is called resonant frequency. So in this way you can find out the expression for resonance frequency is equal to 1 by 2 pi root over lc from xl equal to xc. Thank you.